Hi, everybody. I'm Kobe Marenko. I'm the co-founder and CEO of Arbe. We started Arbe 3.5 years ago with the vision of building the ultimate sensor for autonomous robots, autonomous cars, autonomous drones. And we thought that the ultimate sensor is the one that can work in any day, any lighting conditions, any weather, and the only sensor that can do that is a radar. Radar already generating high quality pictures, high resolution pictures in a military environment. The main problem is that those radars cost around $500,000. They are almost on the size of a big table, and they need a very high power. So we needed to solve those three challenges: to reduce the radar to a size of a mobile phone, to put it on a silicon on a size of a coin of 1 euro cent, so it can be in the size that is needed, and to reduce the power consumption. And this is our product. The reason why we thought that radar is a must is because when we are looking on today's car, there is radar already there. But the problem is that this radar is very bad. This radar cannot really detect stationary objects. This radar has a very high level of false alarm. And this radar has a very narrow beam. It means that if you're driving with your adaptive cruise control and someone is getting into your lane, it will take the radar a long time until it will be able to detect it. And during this time, you can crash into it. So this was our claim 3 years ago, and a quarter ago, the American Association of Automotive also agreed with our claim, saying that current systems in the car, even in the Tesla, what is perceived as the most advanced level 2.5 system, is not good enough. Ronnie showed this picture earlier. We are sharing this problem. It's the main problem of a radar in the Tesla. It just cannot detect stationary objects. So today's sensor suite is very limited. And this gap only getting bigger when we are going to level 3 of autonomous for full highway driving, when you need to map the free space, to move to the other lane and to get back. Those complicated situations cannot handled by the radar that exists in the car today. Radar is the only sensor that can reach to the long range. This is the only sensor that can really work in a bad weather. This is the only sensor that can really measure velocity, the Doppler, the relative velocity of the objects. So we believed when we started the company that solving this problem opened us a huge market from the current cars to the robotaxis that maybe will come 5 or 10 years from now. So we are providing today a breakthrough in radar performance. It's a radar with a very high resolution. It's actually the first civilian radar that's generating a real picture, a real imaging radar, pictures that at least a computer can look on it and take decision on that, maybe even human beings. It's a radar that can reach around 300 meters, has a very wide field of view and a very high frame rate, and also very low false alarms. Short video showing the performance. So this is the radar picture, this is the camera. When you see, this is the track driving, it's almost dark, so our radar can detect it and track it and understand that it's a track because the size of the object. And then on the right side, you will be able to see a car. But you see the car mainly on the radar. The car is very close to the track. And now try to find this car on the video. And this camera is much better than any camera that is today in today's cars. So, and here is the camera, the car separated easily by our radar without any false alarms, without any problems in the picture. So this is the ability of our radar to really build an image. What you see here is a 3D picture. There's no height, there's no the elevation. With the elevation, with the height, we are able also to understand how high is that. If there is a bridge, if there is a car below the bridge that standing there and might influence the conditions. So it's a scalable platform. It's a transmitter, receiver, and a processor. You can take one transceiver, one receiver, and one processor and put it on the front end and get a radar in half of the price of today's radar with 20 times better performance, or you can add more chips and build the full imaging radar for level 5. There is also configurations in the middle for level 3. The idea is that we are able to increase dramatically the performance and to reduce dramatically the price. On the competition in the radar, today there is 5 companies that building that has a chipset, a working chipset for the radar. 3 of them are the existing players, TI, NXP, and Infineon, and there is 2 startups like us that doing the next generation of the chipset. Majority of the tier 1s are producing radars. We are engaged with part of them already, and they already choose our chipset for their next generation radar. So it's a radar for those who safety matters to them, and it's also a radar that you can really base a full autonomous car just on the output that is coming on it. Frost & Sullivan recently recognized us as the leader in next generation radar. We have other applications outside of automotive too.